All right, today we are going to kind of culminate a lot of learned this year into one brief review lesson. So these are all the types of equations that you should know how to solve. Either you learned them in Algebra 1 or you learned them in Algebra 2, sometimes a little bit of both. So again, if you need to specifically review one type more, you're going to have to go back and watch the actual instructional video. This is just meant to be a brief synopsis to refresh your memory for those of you who just need a little bit of a jog. So linear equations, obviously, those should be pretty easy to solve. We have the variable to the first power. We need to get a loan. There are lots of ways that you could correctly do this. Now, what most people try to do is they try to do 3 minus 3/4, and so they do 1/6 x plus 2 equals 3 minus 3/4 is 2 1/4, which is 9/4. Then they subtract the 2, and they say, okay, 2 is 8/4, so 1/6 x equals 1/4, and then multiply both sides by 6. So x equals 6/4, which equals 3/2. Now, if you have a calculator, that's great, and that's pretty easy to do because your calculator can convert it back to fraction form for you, so it can do the 3 minus 3/4, it can do the minus 2, it can do the multiply by 6. But again, you're not always going to have a calculator. So an alternate way to solve this is to multiply by the least common denominator. So if you do that, the least common denominator is 12. 12 times 1/6 is just 2. So you've got 2x plus 24 equals 36 minus 9. And now we're just working with whole numbers. It's a little bit easier to solve here. So we've got the 36 minus 9, which is going to be 27. And then subtract the 24, so 2x equals 3, which again, now you can see you divide by 2 and x is 3/2. So I would recommend when you have multiple fractions in an equation, multiplying by the LCD so that you don't have to deal with fractions every step of the way. Certainly, if you show your work and this makes sense to you, you can certainly choose to do it that way. So, along with linear equations, you learned in Algebra 1 to solve linear systems where you have two variables and two equations, and we've hit these over and over and over again in our flashbacks. So two different methods. You can either use substitution or elimination. I'm going to use substitution on the first one and elimination on the second one just so you have a recollection of both. We use substitution when it's easy to isolate a variable, and in this case, y is already alone. So I'm going to take what y is equal to, and I'm going to put it in place of y in the other equation. So it's going to give me 4x minus 2x minus 5, because all I did was take out the y and replace it, equals 7. So 4x minus 2x plus 5 equals 7. So now 4x minus 2x is 2x. Subtract the 5 from both sides, 2x equals 2. Which means x equals 1. When you know what x is, then you plug it back in. Y equals 2 times 1 minus 5. So 2 times 1 is 2, minus 5 is -3. So y is -3. Remember that on linear systems, we write our answer as ordered pairs. So 1, -3 would be the ordered pair here. The other method to use is the elimination method, where we line them up like terms underneath each other and we try to get opposites on our coefficients. So I could either choose to multiply the bottom equation by -3 and eliminate the x's, or I can choose to multiply the top by +2 and eliminate the y's. Either should get you the same answer. I usually choose to multiply by positives if possible. So I'm going to eliminate my y's, so multiply the entire top equation by 2. So I'm going to write that underneath. 12x minus 2y equals -8. So now add straight down in the columns. 14x, the y's cancel. I get 7 over here. Divide by 14, be careful. It's 7/14, not 14/7. X is 1/2, not 2. So once I have that, then just like in the other method, I plug it back in and solve. So it doesn't matter which one you plug it into. Let's just do the bottom one since it has less writing by it. So 2 times 1/2 plus 2y equals 15. So this becomes 1. So subtract 1 on both sides. 2y equals 14. Divide by 2, and y is 7. Again, list your answer as an ordered pair. So 1/2, 7 is going to be your solution. All right, moving right along, absolute value equations and inequalities. Also review from Algebra 1 that we covered first semester. So when it's an equation with an absolute value, you set up an and. You do 7 plus x equals 7, just like the original. You write and then you do 7 plus x equals the opposite of the original, which would be -7. And then you solve both of them. So subtract 7, x equals 0, and -7, x equals -14. And you can check both of those. Remember, equations you can check by plugging them back in. 7 plus 0, absolute value is 7, -14 plus 7 is -7, and its absolute value is +7. So that works. All right, one thing that people struggle with, and you did these in Algebra 1, we've spent a lot of time trying to keep these fresh in your memory. Absolute value inequalities. We have great ors and less thans. This one is a great or because it's a greater than sign. So what that means is we set up two separate equations similar to what we did over here. So the first one's going to be just like the original, 3x minus 1 is greater than 8. We write or, then we do 3x minus 1, flip the symbol, less than, and change the sign, -8. And now solve them separately. So add 1, 3x is greater than 9, so x is greater than 3, or add 1, that gives me 3x is less than -7, so or x is less than -7/3. Now, even though this isn't a problem, I do want to briefly review what you would do if this were a less than. If this were 3x minus 1 is less than 8, those become a sandwich. Great or less than sandwich. So less than, we sandwich the 3x minus 1 between 8 and its opposite. So this would be the first step if that had been a less than instead of a greater than. All right, quadratics. Lots and lots of time spent on these, an entire unit, as a matter of fact. There are many different ways to solve quadratics. We've already reviewed factoring, spent an entire day and a half reviewing factoring again. So this one's not factorable, and not all quadratics are. So when they're not factorable, you can complete the square, or you can use the quadratic formula. Now, I only complete the square if my leading coefficient is 1 and my middle term is even, because I move my c to the other side and leave a blank here, so 7 plus blank, because remember the formula is b divided by 2 squared. So if the b term is odd, it's going to give you a weird fraction, and we don't want to do that. We would rather use the quadratic formula if this were the case, but completing the square is much faster than the quadratic formula for ones that fit this bill, if the leading coefficient is 1 and the middle term is even. So I do b divided by 2, 4 divided by 2 is 2, and square it, so my blank actually gets a 4. And then this side you factor as a PST, so x plus 2 squared, we just went over that review of factoring, equals on this side 11. And so now I can solve by taking square root on both sides. So x plus 2 equals, don't forget the plus or minus radical 11. And when I subtract 2, I get x equals -2 plus or minus radical 11. Now, quadratic formula, you have to know it. Opposite of b, plus or minus, square root. b squared minus 4ac, all divided by 2a. I'm going to show you that you should get the same answer if you use the quadratic formula. So opposite of b would be negative 4 plus or minus the square root. B squared would be 16 minus 4 times a, which is 1, times c, which is negative 7. The whole thing divided by 2 times 1. So if I simplify here, negative 4 plus or minus radical 16 plus 28 is going to be 44 over 2. Now, the reason why completing the square is so much faster is because you generally don't have to worry about simplifying as many radicals. Here, radical 44, you have to know to factor tree that and make that 2 radical 11. And then, additionally, you have to know to reduce the negative 4, the 2, and the 2 that are all divisible by 2 to give you that negative 2 plus or minus radical 11. So, again, if you can, and it fits the form, completing the square is a little easier. If you can't remember completing the square, then the quadratic formula will have to be your way to go. Just don't forget to put the answer in simplest form. All right, after quadratics, we moved on to higher order polynomials. And this one, we always have to start with the graphing calculator. So we graph the function in our calculator first, and we look at it in a standard window. All we are looking at, we don't have to be able to see the whole picture. We don't care about end behavior or any of that right now. We are looking for x-intercepts, where it crosses the x-axis. So if I just draw a quick little sketch of what this guy looks like on my graphing calculator in a standard window, it looks like it crosses the axis a little before 3, possibly at negative 1. It swoops all the way down and then it comes back up and it looks like it crosses at 1. So it looks like my x-intercepts, the ones that are actual integers, because again, we can't tell what the between is, it looks like it crosses at both negative 1 and positive 1. So higher order polynomials, you start by graphing it in the calculator, and then we do synthetic division. So synthetic division here, I put negative 1 because that's what I'm going to choose. You could choose to start with positive 1 also. Then copy the coefficients here, 3, 8, negative 3, negative 8. Remember that you would need placeholders if you were missing any of the exponents. Bring down the first term. Now multiply. Negative 1 times 3 is negative 3. Add 5. Negative 1 times 5 is negative 5. Add, that gives you negative 8. Negative 1 times negative 8 is positive 8, and you get a remainder 0. Remember, if you have graphed and guessed the 0 correctly, you should get a remainder of 0. If you didn't, that means it doesn't work. Now, once you've done that, that means it takes the order down by 1 degree. So this answer means 3x squared plus 5x minus 8 equals 0 is a quadratic we have left to solve. This is factorable. If I use my guess and check method, I need factors of 8 here. So because this is a 5, I know that I have to get them somewhat close together over here. So I do plus 8 minus 1. The insides give me 8. The outsides give me negative 3. 8 minus 3 is 5. So this is factorable. Now, because we were able to see 2, you could do a double synthetic division and then just solve the linear equation that remains. That is totally up to you, whichever way you want to go. But again, if you only had one visible intercept, you wouldn't have a choice but to solve the quadratic. So once I have this factored, now set each one equal to 0. That means subtract the 8 first and then divide by 3. So negative 8/3 is this one that looked between. And this one is x equals 1. Don't forget to list the one that you confirmed with synthetic division. So I've got negative 8/3, positive 1, oops, forgot the negative sign, and negative 1. Remember, number of zeros, unless you have a double root, should match the highest degree. 3 zeros, 3 solutions, degree 3. All right, next type of equations that we solved were radical equations. Remember that you have to get the radical alone first. So here, the radical is already by itself. Once you do that, then you take the power. So if that's a square root, that means I need to take the second power on both sides. On the left side, when you square a binomial, you have to FOIL it. Some of you still just try to square the x and square the -5. We should not be making that mistake at this point. When you square a binomial, you have to FOIL it. X squared minus 5x, which is minus 10x, plus 25. On the right side, when you square a square root, they just cancel each other out, and I just have the x plus 1 left. So now, get all my like terms together. I've got x squared minus 11x plus 24 equals 0. This itself is now quadratic. It won't always be quadratic. Sometimes it might be linear, but I have to solve this. This one is factorable. It's x minus 8 times x minus 3. So that means x equals 8 and x equals 3. Now, on these ones, whenever you have radical or rationals, you have to check for extraneous solutions. If I plug these back into the original, 8 minus 5 is 3, 8 plus 1 is 9, and the square root of 9 is 3. So I got 3 equals 3, that guy works. When I plug in 3, 3 minus 5 is -2, 3 plus 1 is 4, square root of 4 is 2. We don't consider plus and minuses. This doesn't work, which means I have to cross out the x equals 3, and x equals 8 is my only working solution. I wanted to do another of these because I wanted you to remember that rational exponents are radicals. You have to get the radical alone first. So subtract the 4 first. It gives you x to the 3/4 equals 2. Now take the appropriate power on both sides, and the appropriate power here is the 4/3 power. Please do not confuse this with multiplication. It's to the 4/3 power. The 4/3 and the 3/4 cancel each other on the left, but on the right, it's not 2 times 4/3, it's 2 raised to the 4/3. And you need to know what that means. That means the cube root of 2 to the 4th power, because the bottom is always the index, the top is always the power. So cube root of 2 to the 4th power to the 3rd power would just give me a 2, and then I have 1 left over. So 2 cube roots of 2. You can plug that back in to make sure it works. If I have 2 to the 4/3 raised to the 3/4, that just gives me 2. 2 plus 4 is 6. So this guy works, and that is our answer. Next up, Unit 5 was rational equations. So first thing you always have to do with rationals is make sure you've got things factored. So this guy factors into x minus 2 times x minus 5. And when you are solving rational equations where you've got pluses on one side, you multiply the entire thing by the LCD. So I'm going to multiply this entire thing by x minus 2 times x minus 5. When I multiply my first term by that, the x minus 2's cancel, so I just have to multiply the top times x minus 5. On the second term, I had both of them, so they both cancel, and so it's just times 1. Over here, same thing, x minus 2 cancels with x minus 2. I multiply that 6 by the x minus 5. So 1 times x minus 5 is x minus 5. 1 times 1 is 1. Equals, make sure you distribute here, 6 times x and 6 times -5. So this guy is linear, which makes it easier to solve here. So that gives me x minus 4, 6x minus 30. So minus x, it gives me 5x. And on the other side, plus 30, plus 30. So -4 plus 30 is 26, and x equals 26/5. Now these ones you have to check for extraneous solutions too, but you don't actually have to plug it in and see if it works. You just have to make sure it's not going to give you a 0 in the denominator. 26/5 minus 2 does not give you 0, and neither does 26/5 minus 5. So neither of those give you 0, which means this does work and it is a solution. All right, almost there. Logarithm and exponential, these were in the same unit in Unit 6. So on logarithms, you have to get the log alone first. So that means I need to divide everything by -2. So that gives me log base 5 of 7x equals -1. Now, hopefully you haven't forgotten how to solve a logarithm. It's the swoop. 5 to the negative first power equals 7x. So 5 to the negative first power, we don't leave negative exponents, that's 1/5, equals 7x. So then either multiply by 1/7 or divide by 7, same thing. It's going to give me x as 1/35. You have to check for the extraneous. Just make sure it doesn't give you log of a negative. You don't have to check to make sure it works. As long as it doesn't give you log of a negative, it should work. 7 times 1/35 is 1/5, which is not a negative, so that is our solution. Exponentials. There are two different types of exponential equations. Ones where you have to use logs and ones where you can change the base. Here on the left side, these have the same base. So I can use my exponent rules to just add the exponent. So 9 to the negative 2x equals 27. Instead of using logs here, I can rewrite 9 and 27 both in base 3. So 3 to the second power is equivalent to 9. So I just replaced my 9 with 3 to the second power. Over here, 3 to the third power is 27. So simplify on the left, 3 to the negative 4x equals 3 to the third. When the bases match, you can drop them. So that gives you negative 4x equals 3. Divide by negative 4, and x is negative 3/4. Last one. This one, we've got to do some simplifying first because I don't have the base alone. So add 6 first. Negative 10 e to the 2 minus 2x equals negative 60. Then divide by negative 10. So e to the 2 minus 2x equals 6. Now, in order to undo this, I can't rewrite 6 in base e. It's not possible. So I need to use a log to undo my exponentials, just like I swooped into an exponential to undo a log. They're inverses of each other. So I need to take log base e on both sides. The log with base e is the natural log. So I take natural log on both sides. What happens, remember, since this is base e, when the bases match, they cancel. And so the only thing I have left is 2 minus 2x on the left side equals natural log of 6. So I'm going to subtract the 2 first. So negative 2x equals natural log of 6 minus 2. And then I'm going to divide by negative 2. Now, I write this all out before I type anything in my calculator because when I type it in my calculator, I want to make sure I use order of operations. So I type in natural log of 6 minus 2, I press equals, and then I hit divided by negative 2. I don't round in between. You should only be rounding at the end. When you do that, hopefully, you should get 1.04. If you didn't, again, try natural log of 6 minus 2, enter. Make sure the minus 2 is outside the parentheses. Only the 6 should be inside. Then divide that result by negative 2. All right, so that is your less than one class period review of all the types of equations you've learned in both Algebra 1 and Algebra 2. So hopefully that helps. Again, if there's a specific type that you're confused about, you can go check out the actual full-length video. But we will let you know that math is the subject that counts.